Okay, so today we're going to piggyback on yesterday's lesson from 10.1. So a lot of it is very similar, but here's what I want you to concentrate on today. So 10-2, solving quadratic. So yesterday was graphing. Solving quadratic equations by graphing. So we're going to really concentrate on exactly where the parabola crosses the x-axis, if it does. That's where that's our full focus today, and that's a lot of what we use parabolas for, especially in lower level math, meaning below college level math. All right, so we're going to work with, again, that same quadratic, ax squared plus bx plus c. But this time, instead of y, we're going to let y equal 0, right? Because we're using it as a solution. So if we want to know what the solution of the parabola is, we want to know where it crosses the x-axis, the y value is always 0 on the x-axis. So very similar note starts as yesterday, right? So one thing I want you to add, these solutions to a quadratic are called roots, or what else have we called them? Zeros. You have to know both because they're used interchangeably. It depends on who's talking. You'll hear me saying both only because I want you to get used to hearing both of them. All right, so you're going to make two small coordinate grids here. We're going to look at when there is one solution and what did you discover? How is it that we get just one solution? What's sitting? The vertex. So one solution occurs when the vertex sits on the x-axis. So here's my little coordinate grid. You only need like a, I don't know, 3 by 3. And the second one. All right, so if my vertex is sitting on the x-axis, my vertex could open up or down, and I'll still get one solution. It doesn't matter what side of the x-axis that vertex is on. If it opens up or down, still one solution, as long as that vertex is sitting on the x-axis. What you're going to do a lot of today is factoring of the polynomials, and so this kind of solution right here, you get what's called, remember we talked about double roots? And this occurs when you have a perfect square trinomial. Double root means that both of your solutions, because it's a quadratic, that means we have two solutions, both solutions are exactly the same. And so both of these have double roots. All right, so then we could have two solutions. There are two situations for two solutions. One, the vertex is below the x-axis, and the parabola opens what direction? Vertex is below, the x-axis, the parabola would have to open either up or down for two solutions. Which one? Up. Or your vertex is above the x-axis and the parabola opens down. So those are your two situations for two solutions. So we're going to draw what they look like. So draw two more small coordinate grids. So here's an example of our vertex is below. So let's just put it over here below. So this is B, your vertex. And let's say that the roots were here. And then this would be where the axis of symmetry is. So the other root has to be equal distance apart. So it would be over here. So your parabola would look like this if the vertex is below the x-axis and it opens up. This right here is a root. And this right here is a root. Or your vertex could be above the x-axis. And then your roots might be here and then here. What a beautiful parabola I just drew. Awesome. Just pat myself on the back. All right, so there's my vertex, and then this right here would be considered my roots. So there's one root, and there's the other root. And then we have one more situation. What would that be? We've had one solution, two solutions, and no solution. So can I flip this yet? Okay, I'll wait. Are we good? Okay. So our last situation, no solution. Also occurs in two situations. So one, if the vertex is below the x-axis and the parabola opens. So if it's below the x-axis, what way would the parabola have to open for there to be no solution? Down. Or the vertex is above the x-axis and opens up. So two more small coordinate grids. All right, so we're going to show that. So here might be your vertex below the x-axis, and then it would have to open down in order for there to be no solution. Or it could be above the x-axis, and it would have to open up. Neither parabola crosses the x-axis. So there will be no solution. So if I'm asking you to find the solution to the quadratic by graphing, and you graph something in this situation, your answer you actually have to state no solution. You can't just leave it. In the situation where, so tonight, if you're graphing to find a solution, you discover that you have a parabola where the vertex is below the x-axis and opens down, and you know there's not going to be any solution, all I will require you to do is plot the vertex, plot the y-intercept, plot its symmetrical points, as long as the vertex isn't on the x-axis, and then the axis of symmetry, and that's it. I won't make you do 5 points. There would be absolutely no calculation to finding your y-intercept, so it would take you nanoseconds to do. Okay? But you do need to put in the answer no solution. And I'm fine with you not doing a t-chart, not finding 5 points, because if that's our purpose, then you really don't need to do any more. But I do want you to practice the y-intercept and that kind of thing. So I'm going to do a couple of problems with you on your homework. You really only have 2 problems to do tonight for homework, and you ought to be able to get it done before you leave. You can't count them. Ash, you're not on your phone, are you? Just checking. All right, so we are going, first of all, one thing that I want you to notice. Oh, I fixed it. Oh, good, I gave you the fixed copy. Never mind. All right, so here's your functions. We're going to look at number 1. So you're doing yours in pencil. I'm doing mine in pen so you can see what I'm doing. So we're going to look at number 1. We're going to apply everything that we did yesterday to this. All right, so you might want to put above here the same things that we did yesterday. Max or min, remember, we get is the y value of the vertex. And then the equation of the axis of symmetry is always x equals the x value of the vertex. The coordinates of the vertex is x equals the opposite of b over 2a. And then you're going to find the factors by zeroing, right? And then don't we do this one first? So you might want to also write in here that this is first, and then these two are second and third. Yep.
If the zero is always on the top, you just go straight to zero.
What do you mean if the zero is always on the top?
Say because b is 0, opposite of 0, 0.
Oh, yeah. I see what you're saying. That's fine. All right, so then this would be number 4, and you're just going to use your factoring from Unit 9, so you might want to refer to your factoring flow chart. It's that pink sheet I gave you, right? It's Mrs. Murray in a skinny form on a sheet of paper. Love it. All right, then what's your y-intercept? 0c. And then how many points do I really want on here? 5, unless you have a no solution situation, then all you have to do is plot the vertex, the y-intercept and its symmetrical point and the axis of symmetry. Okay? So let's go through the first three for number 1. So the first thing that I have to do is find A, B, and C. Is this in the correct order? Yeah, but are you missing any term? That's what Tristan was referring to. Are you missing any terms? You got an x squared and you got a constant. You're always going to have a y. You're missing your x term, aren't you? So what's A? 1. What's B? 0 because we're missing it. And then what's C? -9. Make sure you keep that sign with it. So then, am I going to open up or down? Because A is positive, I'm opening up, so opens, up, and then we'll come up with that in a minute. So we're going to find our vertex. The x value of the vertex is equal to the opposite of B over 2A. Your B is 0, A is 1, so what is the value of the x vertex? 0. How do you find the y value? Plug it in, right? So y value of the vertex is equal to parentheses for the x minus 9. This is what we're finding, right? Oh, you didn't tell me you couldn't see it. All right, so I'm going to put in this value that we got right here into there. So what is the y value of the vertex? -9. So you actually have to write the ordered pair of the vertex. What do you get? 0, -9. Isn't that also going to be our y-intercept? Yep. All right, so the 0 and the -9 split. The 0 goes to the axis of symmetry. So the axis of symmetry is x equals 0. And the -9 goes to the max or min value. So do I have a max or minimum value if it opens up? Minimum, right? And it equals -9. You can just put a -9 there, that's fine. But this one you have to put the equation. So then we're going to plot our vertex. I'm going to go over here, plot my vertex. 0, -9, so it's way down here. I'm opening up. Am I going to have solutions or not? Opening up. Will it cross the x-axis? Yes. The other thing I'm going to put in here is my axis of symmetry. Like I said, if you want to do that in a different color, you may, if it makes you happier, just the axis of symmetry. You have to dash it and label it. X equals 0. So we're going to find our zeros by factoring. So we are going to let y equal 0, and our quadratic is x squared minus 9. Does that look familiar to you? Go through your flow chart. Is there a GCF? No. Is it a binomial, trinomial, or 4 terms? Binomial. What's the only type of binomial that you can factor? Difference of 2 squares. Is it the difference of 2 perfect squares? Yes. So the factoring pattern for that is a plus-minus pattern. The square root of each of these goes in here. So the square root of x squared is x, so x goes in here, and square root of 9 is 3, and 3 goes in here. So then we're going to set each of these equal to 0. We can do that mentally. When I set x equal to 0 here, what do I get? -3 and +3. So I'm going to go ahead and plot those ordered pairs. Technically, the zeros are as follows. X is -3, isn't y 0? X is +3, y is 0. Those are the ordered pairs for your zeros. And we're going to plot those. So plot them over here. 3, 0, and -3, 0. Are they equal distance from the axis of symmetry? Yes. What is your y-intercept? 0 what? -9. And so that does happen to be our vertex. There's no symmetrical point to that. So we do need 2 more points. So we are going to have to use an XY table. We've already found our solutions, but I want you to get more practice in. So what value do you think would be smart to choose?
1.
I would choose 1. So we're going to plug 1 in, and remember we're plugging it into y equals x squared minus 9. So what's 1 squared? Minus 9? Negative 8. And so if I plot that over here, I'm going to get not very far up. And so isn't the symmetrical point 1 unit to the left? So wouldn't I have negative 1, negative 8? Now you can put a nice shape to that parabola. Isn't it a thing of beauty? So there's 1. Was it easier today? The more of these you do, the easier it should get. So hopefully tonight's homework won't be too bad. Then let's look at, let's talk about number 5. So for number 5, what's A? Negative 1. What's B? 4. And what's C? Negative 4. Technically this opens down, doesn't it? Because A is negative, so it opens down. So what does that mean? It has a max or a min? If it opens down, it has a max, right? Equals. We'll find out what that is. So let's find our vertex. So our x value of our vertex is the opposite of b over 2a. So b is 4. A is negative 1. I end up with negative 4 over negative 2, which is what? 2. So then the y value of my vertex, we're going to plug into the original quadratic. But you have that negative x squared, remember? So negative x squared, I only put parentheses around for the x, plus 4, and then minus 4. So I'm going to take this 2 and I'm going to put it in here and here. So the 2 goes here and there. When you square this, what whole value will you have for this? Negative 4, right? Because 2 squared is 4 times the negative. So I get a negative 4 plus 8 minus 4. If I were you, I would add the negatives first. So negative 4 is negative 8. What's negative 8 and positive 8? 0. So the y value of the vertex is 0. So our vertex is 2, 0. Where is that point? It's actually on the x-axis. So how many solutions are we going to have? 1. Technically, we don't have to solve by factoring because we've already figured it out. But I'm going to show you what that looks like here in a minute. Let's go ahead and put these 2 over here. So the 2 splits. So the x value, 2, goes to your axis of symmetry, x equals 2. Your y value, 0, goes to your maximum value. So your maximum value is 0, or y equals 0. We already know that we're having just 1 0, but it's got to be a double root, right? Here's what I would do. If I had the following, remember we're going to let y equal 0, and currently we have negative x squared plus 4x minus 4. Do we like to factor when x squared is negative? No. So what should we do? I would multiply everything by negative 1, personally. So if I multiply everything by negative 1, I get 0 equals x squared minus 4x plus 4. All signs will change, right? Is there a GCF? Nope. Is it a trinomial, binomial? 4 more terms. It's a trinomial. You should be hoping it's a perfect square trinomial. The fact that you have this sitting on the vertex should be a huge clue that it is, but let's test it. Remember the test for a perfect square trinomial, because I have a perfect square bookends right here. 2AB, right? So 2, my a, what's the square root of x squared? X, what's the square root of 4? 2. That's how I got a and b. So what's 2 times x times 2? Does it match? Yes, don't worry about signs, it matches, right? So immediately I'm going to take 0 equals 1 set of parentheses squared, right, that's the factor pattern. And then what sign goes in the middle? Look at this one here though, right? The second one that we changed, it's negative, isn't it? So negative goes in there. Then you already found the square root of your bookends. Doesn't the x go here and the 2 go there? So you get x minus 2. When you set x minus 2 equal to 0, what do you get? Just 2. And isn't this a double root? So there, that's how we got 1, 0. And then, hang on, question? Where, here? Well, remember this is 2ab we're testing. And isn't this a squared and b squared here? A different a and b than in our original quadratic over here. Right? It's not the same a and b as those. It's in our factor pattern a and b, right? So we have to take the square root of this, which gives us our x, that's our a, and the square root of the other bookend gives us our b. Okay? So you multiply those together and it matches the middle term, don't worry about signs. Okay? Alright, so then what is our y-intercept? 0 what? Look at the original. What's your c? -4. So I have all that I need to plot this. We're going to plot our vertex. Our vertex is to the right 2, up nothing. I'm going to put in my axis of symmetry. I'm going to label it x equals 2. I'm going to put in my y-intercept, which is 0, -4. And is it opening down as we expected? Yes. How far is that from the axis of symmetry? 2 units. So you're going to go 2 units on the right, plot another point, and then we need 2 more points. What would be a smart one to choose? I would be choosing 1. Remember, we're going to be doing y equals -x squared plus 4x plus 4. Yes. Oh, thank you. All right, so I'm going to plug in 1. When I plug in 1 here, what do I get? -1, right? And so this would be 4, and this would be 4. 4 plus 4 is 8. What's 8 and a -1? 7. Does that make sense?
Yeah.
Does it?
Yep.
Oh, because it's a -4. See, why did I know that that didn't make sense? Where would 1, 7 be? 1, 7 would have been up here. Would that make any sense? You need to be smart about, we make errors, right? So, all right, let's backtrack. So this is -1, right? And this is -4. What does that give you? -5. What's a -5 and a +4? Ah, -1. Does that make more sense? Yes. How far is that from the axis of symmetry? 1. So go 1 to the right. What order pair is that? 3, -1. So now you can fill in the shape of your parabola. And you're done. Oh, well, I forgot that I added a problem on here. Let me just point something out to you. Look at number 6. When you go to factor it, what are you going to do first? Take out a GCF first. But for your A, B, and C, you want to leave it as 3, 9, and -12. You can't take it out when you're doing your vertex. Okay? So note to self. And then this one should be factorable. All right? And then on the front, what are you going to do for these two? When you factor them, what are you going to do? GCF. You're missing a constant, so all you're going to have to do, and let's go ahead and factor, let's factor this one for chuckle's sake. Let me show you just on this one what we're going to do. So I'm going to let you do everything else, but I'm going to do the factoring with you right here. So go ahead and put in 0 for y. and x equals x squared minus 6x. So I get 0 equals, what's your GCF? X. Factor an x out. Divide this by x, you get x. Divide this by x, you get minus 6. Then don't you have to set this equal to 0 and that equal to 0? So I've got x equals 0 and x minus 6 equals 0. So this is one of our solutions, isn't it? What's the value of x here? 6. This is the other solution. What are the ordered pairs? This is the x values. What's one ordered pair? 0, 0. And the other one? 6, 0, because that's the x value, right? Remember, we let y equal 0, so both y's should be 0. So these are the values where they cross the x-axis. I'm going to leave it up to you to find the vertex, to determine whether it opens up or down, and all the rest of it. But this one right here, number 3, it factors the same way here. Very similar. Any other questions?